First, you need to talk with your contractor or employer and see where the vendors are coming from. For example, you need to ask them where do the equipments for this part come from. And usually when you're in the modeling process, the employer still hasn't decided yet which company they're going to use to get the fan coil or the chiller or the pump from. Now the trading process might have not happened yet, but the vendors are usually assigned by the start of the program. Now, in order to improve your work quality, first you need to know exactly who the vendors are in order to prevent any redoings, and this is actually because different companies may create a fan coil, for example, with different sizes. And so because of this fact, it can be really helpful to you to know who the vendors are. And if you actually don't know who they are, and you're trying to think how to model the equipment from the renderings of the 5 biggest companies that you can see, it is usually recommended to select a rendering of the equipment with the biggest size. And if you actually do this later on, if you see a change in your vendor and then you'll need to make any changes, you'll have less problems. For example, if you're going to model this fan coil over here, you're either going to select the biggest size or the one that's used in the most plans for this type of design. Now, the people who are mechanics themselves already know this by nature. For example, they know this company makes these parts in these specifications. Now, as we recommended, that's what you should do, so that later on, when you find out who the vendor is, and well, it could be the same size which you're gonna use anyway, so that's fine. But if the size needed was smaller, it's even better. You have even more space to work with. And this is why I said usually try to select the biggest size for your equipment so that later on you'll have less problems to work with. And as of now, you can see the fan coil that we're working with here. Now I can go over here and give it its material that should be galvanized. Let's look for that in the material browser menu. Alright, so we'll select this one, select the use render box and hit OK, and then apply. Alright, so this connection is actually concerning the duct that we have over here. Now you can also assign a parameter to a flow that you have here in the parameter properties. That's to your preference. I'll put this under instance and then hit apply and OK. And these are all preferential parameters. And you can also do this separately for the pipes here as well. And what else? So now I'll save the file, click yes, and then load into project. Override the existing version, and I'll place it right here. So after selecting it, I'll increase its size, and in the dimension section, I'll put in 0.4 for height, because our duct here is 24 by 8, as you know. Hit space, and there we go. That's where we place the duct. And for the length, we'll put in 0.7 for L. And then for the W, I'll put in 1.25. Alright, then using the move tool, I'll select this corner. Then I'll go over here and hit tab. Alright, and there we go. So for this part, we actually have a collision. So I'll select this and then I'll increase the height under the offset from host. I'll put in 2.95. Then I'll have to put the discipline under coordination, which it already is. Then I'll go over to the visibility, click on override for transparency. It's on 0, so then I'll go over to the Revit Links tab and uncheck the 2 boxes for underlay and hit apply. And okay, now it's better. And you can get a better look at it from this view. And from this angle, you can see it actually has a collision point with the suspended ceiling. So I'll change the offset to 3 meters and then go over to the front view. So now it's practically connected to the ceiling. Let's move it lower, put in 2.98. First 2.95, then 2.97. All right, put in 8 and let's see. All right, change it to 2.99. And there we go. And as you can see, we're using as much space as we possibly can. All right, so then I'll select it and move the depth and bring it over here. So you can see it from this angle as well. All right, so after that, we can see from the side view that we have a wall over here. Well, not wall, the suspended ceiling and the height differential that we've covered. Now let's go over here where I can select the view range and click edit and put the offset on 3.2. Now that's for the top offset where we can apply as well. All right, now let's go back to the view range once again. Now we don't need to see any minuses in the offsets. Now we can put these on 0 instead. All right, and then you don't actually need to see the sewage in the HVAC sections, but its existence can help you check the collision points better. And you can actually assess the collision points in the 3D view as well. So now I can go over to the visibility section and then to the filters tab, where I can add the sanitary and vent filters and then uncheck their boxes so that we can have them but don't actually have to see them in this view right here. So then under the duct, I can only see the ducts. Oh, it seems like I've made a mistake. Let's get rid of these two over here under the filters. Then we'll need to move the view range back to its original place, which was about minus 0.7, and the top offset on 2 as well. Okay, so now we're done with this part. Let's close it up and then we can proceed to the HVAC parts and open up this level in the plan. We just have to wait for the command to be confirmed, and all right, it's right here. So now let's go over to the visibility section and the Revit links. First, let me select all of the levels. Because we've already worked with filters, now I'll need to put them on none. So now I can go back to the visibility graphics menu, then head over to the imported categories tab, and then select these two boxes and this one as well, just leaving the cooling to be. And all right, we are okay here as well. So we'll hit apply. And then I'll put this on fine settings. Then I'll edit the view range here as well. So open up the view range, and for the top offset, I'll put in 3.2 and then hit apply. Okay, then after that, we can put the plan on shaded settings so that we can see this part more easily. And all right, this is the view that we get. So now we can select the measure tool and put a measuring over here from the edge to the wall and put it fixed on 0.3 so that we'll be able to control it. So now in order to start the fabrication process, we can begin with a transition. Now let's see if we actually have that. All right, scroll through the menu and all right, it's right here. And we can also use the shoe as well, which is down here, and it fits the plan perfectly. All right, now let's go back to the 3D menu so I can see exactly where I'm supposed to put this. Close this plan, and so then I'll select the shoe and place it right here. Well, actually, because we have a changing size, I can use transition instead, and that will be more suitable. So first, after it's recognized the connection point, we can click on it and connect them up. Then we'll have to control it. As you remember, the ducts are listed with inches. So first, let's go over to the Manage tab and open up the project units, and under the HVAC, we can select the airflow and then edit the format and put it on CFM or UPS or whatever settings that's to your preference. But be sure to match up the settings because they're actually unique for this part. So finally, I'll put this on cubic feet per minute and select that under the unit symbol as well and hit OK. And then after that, we'll get to size. We just have to look through the menu to find the duct size. There we go. I'll right click on the format and put the unit on fractional inches. Then we'll put the rounding to 1/4 and hit OK. OK. Now the specifications that we are given here are in inches, and we can also control them based on the original design.